So this video is going to follow on from our previous one where we took some experimental data shown here and we looked at how you can use the average function in Google Sheets to work out the average of each of the 5 trials for each drop height in this data. Now we're going to look at how you can actually graph that data. So when we want to graph our data, the first thing we need to realize is most of the time we only want to graph at average values. So what I can do here, I can click and drag over all of my data like that, go to insert, pick a chart, which is another name for a graph, set it to a scatter, which we'll talk about later. Let's talk about why that's important. And we get that, which is just a mess, right? What we have there is we have for each of the different drop heights, we have a value for each of the 5 trials plus a value for the average as well. And that makes it really hard to read. So what I've always said to my science students is that you just graph the average values. If you want to see what the individual trials look like, you can go back and look at the table. So I'm going to get rid of that and I'm going to highlight the drop height and the average. And that's the only thing I'm going to graph, the drop height and the average. But when I try to do that, if I click and drag over that and then try to click and drag over that, doesn't work. So if I want to click and drag over the drop height and then over the average, I need to click and drag over the drop height first, then hold down the command button on the Mac or control button if you've got a Windows computer, and then click and drag over the average value. So now I've highlighted the values in those 2 columns. From there I should be able to go insert, chart, and there we go. So in science, we normally want to use a scatter chart. So if you press chart type here, there's a whole bunch of different ones you can use. We want to use the scatter chart. And from there, there's a couple of things we need to change, right? So Google Sheets will do its best to try to give you what you want. It's done a reasonably good job here, but there's a few things we want to change. For starters, we need something a bit more descriptive. So it's the average time there in seconds, and drop height's fine there. I guess the other problem we have here is that both our horizontal and vertical axes should start from 0, right? Our vertical axis does, that's fine. Our horizontal one starts at 0.5 rather than 0, so we need to change that. So the way we can do that is we can actually click on the horizontal axis, and then over here where it says this window on the side, or this bar on the side where it says customize, this is where we can change things. So the one we want here is where it says min and max value. So I want it to start from 0 and go all the way up to, I don't know, 3 or something like that. Then there we can see all of our different points. It starts from 0 like it should, so that's looking pretty good. And then the last thing we want is we want to add a trend line, a smooth curve that kind of goes through the middle of our points. So how to do that in Google Sheets can be a little bit confusing because it's kind of hidden in an unlikely place. To do that, we go to Customize, then we go to Series, and then if we go down, it has a bit here, a tick box that says trend line. From there, it's a matter of working out what trend line fits your data the best. So the idea here is that if you had a perfect experiment with no errors in your measurements, then you would get exactly the same time for each trial you do. And then when you drew your graph, you'd have a perfectly smooth curve for your graph. And all of your points would line up with that perfectly smooth curve. But if we look at our actual data here, we don't get exactly the same value for all of the trials. Some of them are bigger, some of them are smaller. And in our graph, no matter what we do here, we're probably not going to find a curve or a line that all of our points lie exactly on. Some of them are going to be a little bit above, some are going to be a little bit below. We call that scatter, right? And this is why this is a scatter chart. The idea is the scatter chart shows the effect of errors in your measurements. The more the points are either moved up or down from where they should be, the more errors you have in your experiment and the more they've affected your results. So we put our points in and then we add a trend line that kind of runs through the middle of those points. We're not joining the points together, because if we did that, then we wouldn't be able to see the effects of errors. So anyway, we've got our trend line. The straight line looks like a pretty good fit, but if we think about it, there's probably a better one we could do, because if we follow that straight line back, we can see that the graph crosses the vertical axis, the y-axis here. So this would be a drop height of 0, and this would be the time it takes to hit the ground from a drop height of 0. Now, if you're dropping from a height of 0, you're basically dropping it from on the ground. So it should take 0 seconds to hit the ground if you're dropping it from the ground. So with that logic, our graph actually has to go through the origin. So it looks straight here, but it has to sort of curve inwards, so it passes through the origin where the vertical and horizontal axes meet. So maybe I try something else. That doesn't work. That sort of works. That sort of works. That sort of works. You just kind of use your judgment and pick the one that looks best for your set of data. That one is probably my bet there, the power series one. Still not perfect. Those points don't lie exactly on that line, but it seems to fit the data a little bit better than the other ones we tried, particularly since we know it has to go through the origin. So our graph doesn't actually go all the way back to the origin, we can see it's heading in that direction. So that would be like an appropriate graph. So from there, I could take that graph and like put it into my Google Doc or something like that. So this is something that you can use for science when you're doing pracs and you're putting a graph of your results in your prac report, or you could also use these same ideas for using direct investigations in mathematics as well.